Hello friends, today let's discuss some questions related to conservation of momentum and impulse. Myself Hemaja, BTech second year from IIT Hyderabad. Before getting to solve the questions, let's have a brief recap of what is conservation of momentum and impulse. Law of conservation of momentum can be stated as follows. In the absence of a net external force on the system, the momentum of the system remains unchanged. Let two masses m1 and m2 be traveling with initial velocities u1 and u2 in the same direction along the same straight line such that u1 is greater than u2. Let the collision take place. Let v1 and v2 be their velocities after collision. Then, by law of conservation of momentum, we have m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. What is impulse? Impulse can be defined as the change in momentum that an object experiences during an interaction. That is, delta P equals to F net into delta T. Now let's try solving some questions. A cannon of mass m1 equals to 1200 kg is located on a smooth horizontal platform, fires a shell of mass m2 equals to 300 kg in a horizontal direction with a velocity v2 equals to 400 meter per second. What is the velocity of the cannon after its shot? The net external forces acting on the cannon is zero, since pressure of the powder gases in the bore of the cannon is an internal force. Let v1 be the velocity of the cannon after the shot. The initial momentum of the system is zero. Hence, the final momentum of the system must also be equals to 0. That is, m1 v1 plus m2 v2 equals to 0. Solving mathematics of it, we get v1 equals to minus of m2 v2 by m1. Substituting the values in the equation, we get v1 equals to minus of 300 kg into 400 meter per second divided by 12,000 kg, which turns out to be 10 meter per second. Hence, the velocity of the cannon is 10 meter per second. Negative sign indicates that the cannon moves in a direction opposite to that of the bullet. Let's try another question. A hockey player applies an average force of 80 newtons to a 0.25 kg hockey puck for a time period of 0.1 second. Determine the impulse experienced by the hockey puck. Let's observe the given data. Average force is given to be 80 newtons. Time period of impact is given to be 0.1 second. We already know that impulse delta P equals to F net into delta T. Substituting the values, we get impulse equals to 80 newtons into 0.1 second. That turns out to be 8 newton second. Hence, the impulse experienced by the hockey puck is 8 newton second. Let's try another question. A swimmer with a mass of 75 kg dives off a boat with a mass of 500 kg. If the swimmer's speed is 4 meter per second immediately after leaving the boat, what is the speed of the boat immediately after the swimmer left? In this case too, the net external force acting on the system is 0. Let v1 be the velocity with which the boat moves immediately after the swimmer leaves the boat. Since the initial moment of the system is 0, from conservation of momentum principle, we have m1 v1 plus m2 v2 equals to 0. Solving the math, we get v1 equals to minus of m2 v2 by m1. Substituting the values in the above equation, we get v1 equals to minus of 75 kg into 4 meter per second divided by 500 kg, which turns out to be 0.6 meter per second. Hence, the velocity of the boat is 0.6 meter per second. Negative sign indicates that the boat moves in a direction opposite to that of the diver. So friends, I hope you understood the topics covered in this session. I wish you all the best. Thank you.